Hello, students and fellow researchers. I am going to discuss statistics, the plural of statistic. Many of you generally think that statistics is either a body of knowledge or a tool that deals with the collection, organization, and analysis of data. There could only be a few of you who may be aware that statistics is the plural of the word statistic. Statistics, as the plural of the word statistic, is very important to researchers who cannot cover the entire population of their study and must rely on data taken from a sample. Statistic is the descriptor of a sample. A characteristic of a sample arising from the summative computation of data taken only from such sample, such as the average age of some of the female residents of Barangay Ginebra. General examples are sample arithmetic mean, sample correlation, sample variance, and sample standard deviation. Researchers settle for sample data for a number of reasons. One, it will be very costly to cover an entire population. If your population size is 66 million voters, spending 1 peso per voter respondent will already cost you 66 million pesos. Second is, it is suicidal. If you need to analyze your blood, taking the entire population of your blood will drain you to death. Third is, it is impractical. If you cook and shall sell 10,000 pieces of putu or rice cake and would like to know if they are delicious, if you taste all of them, no one else will buy them. So you settle for sample data. Parameter is the descriptor of a population. A characteristic of a population arising from the summative computation of the entire data taken from such population, such as the average age of all the female residents of Barangay Ginebra. General examples are population arithmetic mean, population correlation, population variance, and population standard deviation. These are the examples of statistics, the plural of statistic, and parameters. If the descriptor is arithmetic mean, the parameter is population arithmetic mean, symbolized by mu. And the statistic is sample arithmetic mean, symbolized by x bar. If the descriptor is standard deviation, the parameter is population standard deviation, symbolized by sigma. The statistic is sample standard deviation, symbolized by S. If the descriptor is variance, the parameter is population variance, symbolized by sigma squared. The statistic is sample variance, symbolized by S squared. If the descriptor is relationship, the parameter is population relationship, symbolized by rho, and the statistic is sample relationship, symbolized by small letter r. And if the descriptor is difference, the parameter is population difference, symbolized by capital letter D. And the statistic is sample difference, symbolized by small letter d. A grave concern of many researchers is that they would like to enjoy both worlds, saving, being safe, and being practical on a sample on one hand, and making conclusions and recommendations for the entire population on the other. Fortunately, this is statistically possible by inferring from the sample to the population, by using the statistic, not the parameter, to describe the population. In most researches, this is called testing the significance of the relationship or the difference or inequality. My students and fellow researchers, I hope you have seen the potentials and great value of a sample and the power of inferential statistics from this lecture. Thank you for watching and listening.